everyone. This is Suraj Jartargar. Currently, I'm studying in 5th SEM Civil Engineering Department. So today we are going to study about highway engineering. In that highway engineering, we are going to discuss about cross sectional elements. So we are studying highway engineering under the guidance of our Professor Manjana H sir. So today we'll learn about some topics about cross section elements. So starting from let us start. So here highway cross section elements. So there are some of the four types of elements. There are pavement surface depends on the pavement type. The pavement surface type is decided based on the availability of materials and funds, volume and composition of traffic, subgrade and climate conditions. The important characteristics of pavements are the friction considerations, unevenness, light reflecting characteristics, and drainage of surface water. So cross-sectional elements are total divided into four types. They are characteristics. So they are friction considerations, unevenness, right reflecting characteristics, and drainage of surface water. So under that, first comes the friction. So let us start about this friction. Friction between the wheel and pavement surface is a crucial factor in the design of horizontal curves and thus the safe operating speed. Further, it also affects the acceleration and deceleration ability of vehicles. Lack of adequate friction can cause skidding or slipping of vehicles. So here comes skidding happens when the path traveled along the road surface is more than the circumferential movement of the wheels due to friction. Second comes the slip occurs when the wheel revolves more than the corresponding longitudinal movement along the road. So in this friction, there are skidding happens and slip occurs and some other. Then next comes the second point, unevenness. It is always desirable to have an even surface, but it is seldom possible to have such a one. Even if a road is constructed with high quality pavers, it is possible to develop unevenness due to pavement failures. Unevenness affect the vehicle operating cost, speed, riding comfort, safety, fuel consumption, and wear and tear of tires. So in unevenness, there are some effects for vehicles and for humans also. So for safety, comfort, etc. Then next comes the light reflection. Light reflection, white roads have good visibility at night, but cause glare during daytime. Then second comes black roads has no glare during day, but has poor visibility at night. Concrete roads has better visibility and less glare. So it is necessary that the road surface should be visible at night, and reflection of light is factor that answers it. Then next comes the fourth one, drainage. The pavement drainage. Then the pavement surface should be absolutely impermeable to prevent seepage of water into the pavement layers. Further, both the geometry and texture of pavement surface should help in draining out the water from the surface in less time. Then next comes the camber. Camber or cant is the cross slope provided to rise middle of the road surface in the transverse direction to drain off the rainwater from road surface. So in that drainage we study about camber. Then here are some types of cambers and IRC values of cambers. So here you can see that surface type, heavy rain, light rain. Concrete bituminous percentage 1%, light rain is 1.7, gravel then 2% of heavy rain and light rain of 2.5 percentage. Earthen has a heavy rain of 3 percentage, then 3.0% of light rain. So here you can see some more types of cambers: parabolic camber, straight line camber, combination of straight and parabolic camber. So here are some more types of cambers and IRC well for cambers. Then next comes the width of the carriageway. Width of the carriageway or the width of the pavement depends on the width of the traffic lane and number of lanes. Width of a traffic lane depends on the width of the vehicle and the measurements. Side clearance improves operating speed and safety. So here you can see a table IRC specifications for carriageway width. There are some specifications of IRCs. So you can single lane have 3.75, two lane has no curbs, it has 7.0, two lane raised curve 7.5, intermediate carriage 5.5, multi lane 3.5. Then next comes here about curves. We are going to curves indicate the boundary between the carriageway and the shoulder or islands or footpaths. There are some different types of curves. You can see lower mountable curves, semi-barrier curves, barrier types curves, submerged curves. So here we can see four types of curves. So in that this type, first about mountable curves. This type of curves are provided such that the encourage the traffic to remain in the through traffic lanes and also allow the driver to enter the shoulder area with little difficulty. The height of this curve is about 10 cm above the pavement edge with a slope which allows the vehicle to climb easily. This is usually provided at medians and channelization schemes and also helps in longitude drainage. Then next comes about semi-barrier type curves. When the pedestrian traffic is high, these curves are provided. Their height is 15 cm above the pavement edge. This type of curve prevents encroachment of parking vehicles, but at acute emergency, it is possible to drive over this curve with some difficulties. Then next barrier type curves, they are designed to discourage vehicles from leaving the pavement. They are provided when there is a considerable amount of pedestrian traffic. They are placed at a height of 20 cm above the pavement edge with a slip pattern. Then next are submerged curves. Submerged curves they are used in rural roads. The curves are provided at pavement edges between the pavement edges and shoulders. The private lateral conformment and stability to the pavement. So these are some four types of curves here you can see. Then next comes the road margin. In road margins here you can type you can see seven types of margins that are shoulders, parking lanes, bus bay, service roads, cycle track, footpath and guardrails. Then here comes width of formation. Width of formation or roadway width is the sum of width of pavements or carriageway including separators and shoulders. This does not include an extra land in formation or cutting. So next there is a table the values suggested by IRC. So here are some values that are suggested by IRC. So here you can see road classification, road width in M, road width in M, then plain and rolling terrain, mountainous and steep terrain. In NH or SS, there are plain and rolling terrain for 12, then mountainous and deep 6.25 to 8.8. MDR there is 9 and 4.75. ODR has 7.5 to 9 m. In mountainous and steep terrain has 4.75 m. VR has 7.5 m of plain and rolling terrain. Then it 4.0 for mountainous and deep terrain. So here width of the formation for various classes of roads of there are some IRC values. Then next comes the right of way. Right of way or land width is a width of land acquired for the road along its alignment. It should be adequate to accommodate all the cross section elements of the highway and may reasonably provide for the future development. To prevent ribbon development along highways, control lines and building lines may be provided. Control lines is a line which represents the nearest limits of future uncontrolled building activity in relation to a road. Building line represents a line on either side of the road between which the road no building activity is permitted at all. So here are some here the two tables here we can see. Then road classification as we have seen before, plain and rolling terrain, mountainous different or open. For open areas NH has 45 meters and 24 meters for mountainous and steep terrain. MDR has 25 meters for plain and rolling terrain, 18 meters for mountainous and steep terrain. ODR has 15 meters for plain rolling terrain, has 15, both are same for 15 meters. Then VR has 12 meters for plain and rolling terrain, then 9 meters for the mountainous and steep terrain. So these are for open areas. So what about the built up areas? Built up areas for 30 meters for NH and 20 meters for mountainous steep terrain. MDR for 20 meters. Then for this 15 meters, this is 15, there is 12, and this last one VR has 10 meters and 9 meters for mountainous and steep terrains. So summary of this cross section elements. So here last comes the summary of this cross section elements. The characteristics of cross section elements are important in highway geometric design because they influence the safety and the comfort. Camber provides for drainage, frictional resistance and reflectivity for safety, etc. The road elements such as curbs, shoulders, carriageway width, etc., should be adequate enough for the smooth, safe, and efficient movement of traffic. So, IRC has recommended this minimum value for all these cross-sectional elements. So, here all the summaries that we studied before for now. So, what are all the concepts we studied here? Here is a small summaries there that the character of cross-sectional elements are very important for highway geometry design because they influence the safety for humans, obviously for humans, for our safety, then for our comfort. So as we study chambers provide for drainage, frictional resistance, and reflectivity for safety. Then the road elements such as curbs, shoulders, carriageway width should be adequate enough for smooth, safe, and efficient movement of traffic. So this is the small traffic we have studied cross-section elements. So here are some points we have studied the important characters of pavement. Then in brief, we studied about friction, unevenness, light reflection, drainage in that chambers. Then we studied about curbs, then the width of carriageway, and types of curbs. Then road margins, shoulders, parking lanes, bus bays, service roads, cycle tracks, footpath, guardrails, and then we next width of formations. We have studied some tables about width of formation for various class class of roads. Then next right of way we have studied for open areas and built up areas. Then this is the last summary of study. So this was the small topic about cross sectional elements I wanted to say. So thank you.